In our previous videos, we looked at how to use law of sines to solve a triangle, any triangle, not just a right triangle. In this video, we're going to take a look at how to use the law of cosines. Now, law of cosines is different than law of sines. You're going to know to use it when you don't have an angle pair relationship. So in this case, there's no side and angle I know for either A, B, or C. So since nothing lines up, that's what's going to tell me to use law of cosines. And a quick note down here, we talked about this with law of sines as well. When you're using law of cosines and you have a choice of which angle, which you won't always have, make sure you find the largest angle first when you're doing law of cosines. The smallest angle if you're using law of sines. This is because law of cosines, inverse cosine, will be the only way to find you obtuse angles if there's one lurking in your problem. Alright, anyway, let's start our problem. So what I'm going to suggest first is if you don't know all three sides, find that missing side first. So the way law of cosines works is this. Take your missing side squared, and that's equal to the sum of the other two sides squared. At this point, it seems a lot like Pythagorean theorem. B squared is equal to 11 squared plus 14 squared. But remember, this is not a right triangle, so there's a bit of an adjustment that needs to be made. And that adjustment is to subtract 2 times, repeat the two sides, so times 11 times 14, and then cosine of angle B. Whatever side you start with, since we started with side B, we're going to end with angle B here, so this is cosine of 34. So that's kind of how I think of setting these up. Alright, so from here it's a lot of calculator work to simplify this. So B squared, I'm going to do this in pieces, although you certainly could, in this case, type them all in at once. I'm going to show you kind of this in pieces just so we don't make any mistakes, especially as these get a little different or a little more difficult in the next video. What you got to be really careful of is recognizing that all this right here is one single term. So these pieces can't be added or subtracted separately. It's all one piece. So I've got, I like to do this multiplication first. Negative 2 times 11 times 14, and that comes out to be negative 308 times the cosine of 38. Or 34. So once again, this is all one big piece here that can't be separated. Going ahead and adding some pieces together then, 121 and 196 add up to 317. And then this part right here, I used my calculator, I typed in negative 308 cosine 34. That comes out to be about 255, excuse me, 0.34. Sorry, checking my notes. Again, you could do this all in your calculator. I'm just showing a lot of steps this time. Subtracting those gets me 61.66, and then taking a square root, I find side B comes out to be about 7.85 after all that work. Okay, so let me go ahead and add that to my chart just to keep my information all in one place, so 7.85. And now what I need to do, well, I still have two missing angles to find, but take a look at what I have now. Most people don't like using law of cosines. It's a lot of work. People like law of sines. They like the simple proportions. And look what I have now. Now I have an angle-side relationship. I have an angle-side pair. And so what I'll do is I'm going to switch over and do law of cosines from here to avoid having to do law of sines again. So recall that law of sines worked like this. It was sine of angle B over side B, as long as I have those matched up. And then I can find either angle next. Well, here's where I have my choice. And since I've switched over to law of sines, I'm going to make sure I find the smallest angle next. You've got to do it this way because there could be an obtuse angle lurking in this problem, and I won't be able to find it with law of sines. I know that angle A is the smallest angle because it's across from side A, which was the smallest side. So anyway, all this is to say, let's set up sine of angle A over side A, which was 11. Okay, from here, let's go ahead and cross multiply to find out what side A is equal to. So let's see, I'll cross multiply this way first. That just gets me 7.85. Oops, angle A. I think I said side A. So sine, I can't talk right now. 785 times the sine of angle A is equal to whatever I get when I cross multiply this way. Make sure you're in degree mode still. 11 times the sine of 34 comes out to be about 6.15. So what I'll need to do is divide both sides by 7.85. So sine of A is going to be equal to 0.78. And finally, doing an inverse sine to find angle A, I find that angle A, and if it comes out, or never mind, get that in a second, angle A comes out to be about 51.58 degrees. So let me go ahead and add that into my table as well. So I've got almost all my information now. So this was 51.58. And now what I'll do, again, these problems are really long. So what I'll do to save time is, since I know the angles of any triangle add up to 180, since I now know 2 of them, let's go ahead and just subtract each of those angles from 108 degrees. And I find out that angle C is 94.42 degrees. And what's curious about this problem, and I want you guys to check this out for yourselves, this angle was obtuse, meaning I cannot find that angle doing an inverse sine. An inverse sine only gets you acute angles on your calculator. So instead of, here's what I want you to kind of try on your own, instead of doing what we did here, suppose we go back in time and retry this problem, finding sine or finding angle C first. If you repeat this whole process, you'll find out that you do not get 94.42. The only way to find that, the way we did it, is to find it last and subtract from 180. So go ahead and investigate that, but just as we talked about, make sure when you have a choice, like we did in this one, use law of sines to find the smallest angle first, just in case you have one of those obnoxious, obtuse angles in your problem.